Hi guys, this is Vijay. Welcome back to my YouTube channel. Today we are going to discuss about a topic called self-attention in transformer architecture. This self-attention says the main point of self-attention is how can a AI read a sentence. As a humans, we can understand a sentence easily, but as a machine, how can a machine read the sentence and understand the context of it? uh, so for this agenda, we are going to see self attention concept in transformer architecture. So let me write it here: self attention mechanism in transformer architecture. So let me consider one sentence uh, like the animal cannot cross the road, or the animal cannot cross the street because it was too tired. So this is the sentence we are going to consider as an example for this video. Here, as a human, we can understand that uh, here the word it is going to be referred to animal, right? We know it is going to be referred to animal, but how a machine uh, knows that whether it is referring to street or animal or other words in the sentence, how it can understand? So for this context, uh, there are three parameters we are going to define. Simply, we can say that we are going to calculate a attention score for this mapping. uh, Here the word it is mapped to animal, so this mapping will have a score of some 0.9, and the other words it mapped to will also have some score like 0.5, and other word 0.1. Here the numbers are not randomly generated, it are calculated and given. It will give the context, semantic meaning of the relationship between the two words. So uh, here the probability of connection or relationship between the word it and animal is 0.9. That means it is referring to animal. This is called as attention score. So how can we calculate attention score? There are three parameters over here: q, k and v. Q means query, k means keys, and v means value. So let me tell you clearly here. I want to calculate the score for it, the word it, how it is related to other sentences in the same sentence. So the remaining words in this sentence are the animal cannot, and so on till tired, right? So here this word is converted into a numerical vector like this. For suppose it contains 64 numerical values. These are called as dimensions. The word is converted into embedding vector with some number of values. These are called as dimensions. So this is mapped or with every word. Every word in the sentence will have the vector like this. Numerical vectors. Right? So for each word we will do the dot product. Right? Q into K. Here the relationship between these two Q and K is dot product. So for every dot product, this dot product only goes maximum value when both are 1. If one of the vector is 0, then the product will be 0. So right, obviously here animal will contain the vector. This vector will contain values that are much higher, and the word it also contains the values that are much higher. This product goes maximum when it gets multiplied using dot product. So this one will be normalized using a number of dimensions present in the keys. So this product will obviously be a bigger value. So the numerical value is a bigger value. So to normalize it to a lower value, we are doing the division with number of dimensions using a square root value. And after doing this, we will calculate a probability value using softmax function. This will give in the range of 0 to 1. So after calculating the probability, we will do the multiplication with the value vector. This value is nothing but the vector, numerical vector that numerical vector that has the meaning or essence of the word. So here the word animal has some value that is captured in this value. We will do the multiplication with that value. So to understand it even more easily, I will give you an analogy for this. This is attention score. Attention score, which is a function of query, key, and value. So I will give you an analogy easily so that you can understand it quickly. Let's see, there is a party going on. In that party, there are a few people attended, like let's name them as A, B, C, D, and so on up to I. So these are the people in the party. let's say one person named B, shouts loudly and asks a query that who here knows the rocket science. This is the query asked by the person B. Let's name it as Q. Then the remaining people, let's write all the persons as here. So these all persons will have some tags attached to them, right? A person may be a chef, B may be software engineer, and C may be a musician, D may be a electrician, and so on. Let's say G might be a rocket scientist. So in all of these persons, the better person will be G to answer the query asked by B, right? So here the dot product will be maximum when if we assign the score, this person dot product will be 0. B and A dot product will be 0, as chef don't have the knowledge of rocket science, right? So similarly, a software engineer also don't have the knowledge of rocket science. So the score will be 0, and all of them will be 0 here. Coming to G, person G, he has the exact knowledge query asked by the person B. So the score will be 1, right? So the dot product here we do will be maximum when query and key context has matched, and the score will be maximum when we do the dot product. To normalize this bigger value, we are doing the square root of number of dimensions. This is our attention score, initial attention score. So B will obviously listen to what G says, right? This is our value. What the G says is our value. So this is called retrieval. That's why we are going to multiply this attention score with value. Before multiplying this, we need to convert this attention score into a probability value ranging between 0 to 1. So that's why we are going to pass this to a softmax function. So that's why softmax, this will give you the probability range in between 0 to 1. So this is how an analogy of party can be used to explain the attention score for how a word relates to other word. So in this sentence. Coming to our example, the animal cannot cross the street because it was too tired. The transformer, in the transformer architecture, it has encoder and decoder models. Let's see that encoder decoder in another video. The point of this video is the self attention. So each word will be mapped to every other word, and there is a score getting calculated for this mapping. Similarly, here it is also getting mapped to all other words. So the for every mapping we are going to calculate the attention score. For example, if we see another example, like a sentence, Hyderabad loves biryani. This is a sentence. Let's consider this sentence and draw a heat map. Hyderabad loves biryani, and I will write the same sentence again in x direction. Hyderabad loves biryani. I will draw a grid like this. So right, in this grid, each word will be converted into a numerical vector Q, K, V. 3 vectors. For every word there will be a mapping of Q, K, V. And then these vectors will be used to calculate the value inside this grid. So the probability value here will be some value. Let's assign some, assume some values here. Like this, the heat map will be generated. This is our heat map. How can we evaluate or validate this heat map is the two words here, Laos and Hyderabad, has some value here, probability value. The higher value indicates that the relationship between the two words is stronger. Same here. If we examine this sentence, it is going to refer to animal. That means it is a living being. The word will be the score should be a stronger value, and street is something, a concrete material that cannot be a living being. And the two words street and tired are not going to be related to each other, so the score should be 0, approximately 0, right? Street is never going to get tired. So this way the self attention mechanism is going to be processed in the behind the scenes in the transformer architecture. Let's see the heat map example in the next page. This one I have written the program, and I will show you this code in the next video to calculate how the scores are getting calculated. So you can see in this heat map, the word here the word it is this is our line heat map. The word it has higher value over here, right? This is our value that is relating to animal. So this indicates that the relationship between it and animal is stronger, and this is always pointing to the word animal. So I hope you understood the essence of this video, guys. um, the essence of this video is here how the AI is going to understand the sentence as a human. uh, in previously before 2017, one more point I want to update here. In 2017 this paper was released. Before that it is the neural networks or NLP was processing sentences in unidirectional way. After 2017 the transformer architecture has come. It has a bidirectional in nature. So this gave the self attention mechanism to our transformer architecture. So that's it for this video, guys. I will give you the code for heat map generation in the next one for only this sentence, hard coded for the example I have shown. So I think you have understood all the concept clearly, and I will see you in the next one. Thank you.